All right, Oliver's here. I think we can get started. All right. What good would a conference be without a talk about Docker? Come on, people. Or I could say, Docker drives me to drink, but I think that would be an exaggeration. Anyway, my name is Robert Schweikert, and yes, you have to listen to me again. Docker, it is not a silver bullet. Although if you believe the media hype, you would certainly think it is, but it really isn't. And I will tell you why I think that is not true. Okay, so I'll start talking about the claim that is being made about containers in general, especially about Docker, how it is presented to the developer community at large, and system administrators and users and CTOs and CIOs and whatever, you name them. We'll talk a bit about the reality, take a little bit of a deeper look beneath the surface of how things, really look. And when you look at it, then the picture that it's not quite so nice as it is presented becomes relatively clear. I'll give you some general thoughts, and then we'll, ponder about what it means to be a distribution. This is an OpenSUSE conference, after all, in the world of containers. All right, well, let's start with the claim. The claim is, if you are an application developer, package your application and your dependencies, and you're done. And you hand it over to the system administrator, and everything will magically work. Well, let's just say there was a guy, 40 years ago now, that wrote something about silver bullets, right? And that is still true today. So this is the claim. If you believe the hype about Docker and containers, you will see this. Package your application and dependencies, and then you can move that around from development to test to staging to production, and everything will work just magically fine. But this is actually not true, I claim. So it's my counterclaim. The reality is that, well, yes, you can package only your application and your dependencies. And why can you do that? Because Docker in specific has a layered file system approach, and you can see here, you start with something that has a kernel with C groups and namespaces, so you need a kernel that has sufficient technology built in. This is doesn't go back to the beginning of time. So you need to have a relatively recent kernel. That's basically your boot file system. And then you build a container with a base image. It's OpenSUSE, of course. What else would you possibly use? And then you add applications on top of that, in this case, Emacs and Apache. And then on top of that, you have a writable file system layer. So if you make any changes, they basically overlay the other layers, which are read-only. Okay, so anything in this stack that is kind of in blue color, that is read-only. So yes, as an application developer, let's say Apache, you can simply pack Apache. But if you look at Apache, well, it's not just Apache, right? Apache depends on other stuff. One of those funny things it depends on happens to be OpenSSL. Anybody remember Heartbleed? Yeah. So let's say OpenSSL is in my Apache layer, and Heartbleed happens. Now what, right? So the reality is that it sounds great that you're just packaging your application and your dependencies, but then whoever packages that application and the dependencies is also responsible for that application and dependencies, right? So if that layer comes from a free software project, like OpenSUSE, for example, let's say it's going to work that we would produce a new file system layer that has a fixed Apache with, well, not Apache, but a fixed OpenSSL. But let's say this is some third-party software. Then what? Now you're depending on them to give you updated patches, an updated layer in time, right? Okay? So the base container, why do we need the base container? It provides an init system. Okay? Containers need an init system. So it is more than, a container is by definition already more than the application because you need an init system. Okay? There should be an update stack because, well, although that's not required, the container templates you usually get are really basic systems. Okay? So there's nothing in it. Well, there's the init system and that's about it. And so if you want to add anything to it, which adds then up to these layers that we saw, right? These usually happen through an installation process. So if you want to have an installation process, you need an update stack, okay? An update stack is also generally useful if you have to fix security problems. But therein lies the problem, and we'll get to that in a minute, okay? So, okay. Once you have that, then you need a Docker file. Okay, you need to have a Docker file so you can build your container to begin with. Okay, someone also has to release that application layer, as I mentioned earlier, right? You have to have that application layer if you want that application in it, or you install that application layer through your Docker file, right? So there's two ways to get there, right? You can say, I base my new container on some image that has the application already in it, or I base my new image on a base image, OpenSUSE base image, and then run zipper in Apache 2, right? So now you have those layers, or you get the layer from somebody else, okay? And again, if you get the layer from somebody else, then you depend on them to fix any security issues in their dependencies or their application themselves by giving you a new layer, okay? So, well, Heartbleed, something like that, requires security fixes that are basically immediate, right? And this is where distribution vendors or distribution communities such as OpenSUSE have in the past proven really responsive. But third parties may not necessarily be as responsive, right? So there's a trust relationship and a hope that whoever gives you that layer is immediately responsive to when there are zero-day vulnerabilities, okay? And not just that, you also need some kind of service, and this does not exist today, that tells you that these issues exist, right? Today, when you're running a distribution, if you're running OpenSUSE or SUSE Linux Enterprise on your desktop or even on your server, we have PackageKit running generally, and it gives you a little notification and say there are a number of security fixes available, and you should install them, right, if you're running it on your desktop. And for servers, we have mailing lists where you get that. But if you're getting a container from somebody, there's no service like that today, okay? Nobody has a service like that today that tells you, we gave you a container, and you're running that container, and we found that the version of libSSL that we have in that container has a security vulnerability. That service does not exist today, okay? So there is an issue right there, right? You have no notification. So you may be running something, you don't really know what's in it, and you don't know if you're vulnerable, okay? So there's something that needs to be thought about. Okay, or, okay, the other way, of course, is to say, okay, I have an update stack in my base image, and so I just run zipper up, and then the vulnerable libraries get replaced. The problem with that is, well, a container only runs as long as the service that you're providing within the container runs. So if I update and then restart the container, well, my container goes down and I start one from the original image, which of course is vulnerable. So you're caught in this vicious cycle where you can't update the container unless you actually rebuild it, meaning build it from scratch, okay? And so you're in this cycle where you can say, well, okay, so if you compare it to a system on real hardware or in a virtual machine, right? I can go in, I can update the virtual machine, and I can shut down Apache and bring it back up. That takes me a second. And everything is fine because it'll use the new version of libSSL. You can't do that in a container because as soon as you shut down Apache in that container, your container goes away. And when you restart it, you're starting from the original container, which has the broken version of libSSL. Because updates are not persistent unless you commit them. And then as soon as you commit it, you create a new container. Okay? If I run an update in a container, the next step is, if I want it to persist, you have to run commit, which means you are creating a new container. It is no longer the container that you were running to begin with. Right? Yes. It's a Docker talk, yes, yes, okay. So you have to, if you want those changes that you're making with your update stack to persist, then you have to commit your container so that the changes are persisted, but that also means you're creating a new container, okay. You're creating a new container, and then you have to start that new container. It is not the same container, okay. So there's a difference. No, you're committing to your local file system where the containers are stored, okay? Var, lib, docker, wherever, okay? But you have to make that commit, right? And that is not necessarily what people think about, right? People go and say, okay, I'm going to run zipper up and I'm going to restart the service, right? This is a new step that is in the workflow that is not necessarily in the consciousness of the person that, you know, because for 20 odd years, 30 years, the workflow has been, I update the broken library in between, I restart the service, and I'm fine. Well, that doesn't work with containers, right? If I restart the service without committing in between, I'm starting the same container that has the vulnerability built in already, right? And then you walk away, and you're vulnerable, and then you say, but I ran update. Not a problem. You just have to do it. You have to do it. And what I'm saying is, old habits die hard. People are used to update, restart the service, right? That's what everybody's used to. Think about yourself, right? What are you used? What happened when Heartbleed came out? I ran zipper up, I restarted all my services, and I was done. That is what I'm used to. That's what I've done for how many ever years, right? In the world of containers, that no longer applies. Frederick. I'm sorry.
Please repeat. So what about creating a zipper plugin which would use a Docker commit after you run zipper patch? A bit similar to what we do with Snapper.
Right. Yes, so that would be possible. You could automate the workflow. But today it doesn't exist, okay? And we're thinking of ways to make that safer from a SUSE perspective, but today that does not exist. There was another question here. Right, right. So the problem is that if you don't commit in between, you always start the same thing over and over again, which is vulnerable by definition, right? Which is what you were trying to fix with the update stack. So you have to be careful there, right? Yes. Yes. So the question is, if at the end of what you normally do, if you're running in a container, you have to commit, and yeah, the answer is yes. Yes. Right. Right, there's this new step, right? You have to commit, if you're running an update stack in the container and you're running zipper up to make sure it's up to date, and you want to restart the service that runs in the container, you have to commit first before you restart. Because the container shuts down as soon as the service that is running within it, if that process ends, right? In the Docker case, okay? So basically, or if you don't do the commit, then you have to rebuild from scratch. As long as your Docker file, your build script basically contains a zipper up inside of the build script, then you automatically get the latest, right? So this is not as easy as it is proclaimed, obviously, right? So with that, some general thoughts. I'm going okay on time. I'm halfway through. For developers, containers are great, right? Because for us, if I'm developing a web service, I can really have a very fast cycle. Containers build really fast because Docker keeps a cache of what you have built on your system, right? I can rebuild a container in a matter of minutes, right? I can map the application, the web application that I'm working on, that is on my file system, on my machine, on my laptop, I can map that directory into the container and can point the web server or whatever service is running inside to my application that's actually on my file system. And so I can develop and I can recycle and restart that container in a matter of seconds or minutes. It is great. It is really fantastic. There's no question about it. The mapping of directories, also the container is portable, right? So if I'm working with somebody else on my team, I can just tell them, look, go to my GitHub, you know, pull my repository and put it in your home directory. And then here's my Docker file. And now run Docker build and run Docker run. And within a minute, my team member has a duplicated environment of what I have, and we can work on the same code, see the same thing, right? This is very easy. So this is fantastic, right? Okay? And yes, it is a reasonable preview of production, because with Docker and some other tools, I can do orchestration on my laptop of 3, 4, 5 machines that have to be hooked together, a database backend, web front end, and whatever else goes along with it. I can hook that together with Docker containers very easily, right? Docker provides all that infrastructure, and that's very nice, okay? So in the end, it lets me encapsulate what I'm doing into a way that is easily portable, okay? And it lets me focus on the work that I'm doing if I'm developing a web application or some other service. So from that point of view, Docker is fantastic, and I'm a developer. I'm not while I'm developing, my service is not going to be exposed to the outside world. So I really don't care that much about Heartbleed or shell shock or whatever, right? It's just running on my machine. Nobody else can get to it. It cannot be compromised because there's no access from the outside world, and I'm okay. But that does not mean that I can take that then and stick it into production, right? This works great. Developers, whoa, yes, we love that stuff. Systems admins, production environment, not so much, right? Yes, they're easy to fire up. And I can take the orchestration that the developer built and run it on my production system. So from that point of view, there is a translation in make it easy and make it easy in production. But, as I mentioned, the management of security fixes now becomes actually more complicated than it already is today. Okay? And the system that we have today is far from perfect, but it works and we've all gotten used to it. That doesn't necessarily mean we can't do better or we shouldn't change it. But Docker is not really the way I think to go here. Okay? If you're using a layer from an application layer from somebody, then that means you're depending on that somebody to give you a new layer basically immediately. Then you have to rebuild your container from that new layer and then restart that container, okay? So there may be potential downtime issues. If you use the update stack, we already discussed that. You may, if you don't do the commit, you end up in this vicious cycle where you restart it and you actually don't get the fix that you want, right? And overall, as it stands today, there's very little experience, okay, in the systems administration community and the community in general, and there is no best practice for, you know, well, what happens if you deploy 10,000 containers? There are not really best practices available today because nobody has made those experiences yet. We don't really know what's going to happen. This is going to take time. It's going to happen eventually. We are going to know. Best practices will be documented, but we're not there yet today. All right. And now to the more philosophical question. As a distribution provider, as the OpenSUSE project, what does it mean to be a distribution in the container world? So, this one's easy, right? We have a kernel, bootfs, that comes from the OpenSUSE project. We run OpenSUSE on top and applications. Are we running OpenSUSE now? Yes, we are, right? Because everything in the stack comes from the project. It's, you know, it's quite easy to answer. But now what? Now I have some kernel. Maybe I have the upstream kernel. Or I get the kernel from some other distribution. Or I am a kernel hacker and have my own kernel. And now run OpenSUSE on top. Am I running OpenSUSE in that container? So from a distribution point of view, this raises some very interesting questions, right? How do we define ourselves as a distribution? Are we defining ourselves as a distribution of the update stack and all the packages that you may get from our project, which may not necessarily have to include the kernel? Or do we say you're only running the OpenSUSE distribution if you're in this scenario, where OpenSUSE is the base and you're using OpenSUSE, well, quote-unquote user space, right? Because this is more, the base image is more than user space, but let's just say this is user space in the container world, right? Oliver.
Just to play devil's advocate, how is that different from running in a virtualized system?
Excuse me?
How is that different from just running on a virtual machine?
How is it different from running on a virtual machine? Well, because in a virtual machine, whatever is inside the virtual machine runs on the kernel that the distribution provided. The hypervisor itself is really immaterial because it just abstracts the hardware. The hypervisor just says, okay, I'm running on a different set of hardware. So if you run in Amazon today or in Google and you run an OpenSUSE image that we release, you're running OpenSUSE. You're running on top of our kernel, and they use different hypervisors between Google Compute Engine and Amazon. But that's just like saying I'm running on IBM boxes or on HP boxes. No, you're not. You're changing the abstraction layer. That's like running on IBM or it's running on, but you're not changing the kernel. You're still running on the kernel that OpenSUSE or SUSE Linux Enterprise put into that image. So there is a big difference. Anyway, so this is a question that is not easily answered, right? In the container world, from a distribution point of view, I don't think we have an answer for this question today. And with that, I am actually at the end, and so if you have more questions, I'm happy to answer them. Yes? Yeah, so inside Docker, there is really no reason to do that, but you could. You just have to consider that a Docker container, the lifetime of a Docker container ends when the service that you're running within ends, okay? So if you want to have a change root tail inside a Docker container, which is kind of nested, which would be like nested Docker, and that's okay. That means you have to run one process in the outer layer, in the outer Docker, that basically persists, right? You could run an interactive shell and leave that up in a terminal running forever, right? Or send the output somewhere. But then you have to do a service that you don't have to change, that will never go away. So as soon as that service ends that runs the outer Docker, your change root jail also will go away, right? Because the container will be shut down, right? I mean, you could map a change root jail from your file system into that change root jail that you're running in the container, but I'm not certain that is really useful use case. Gabor.
I was wondering if in your experience, are there any larger customers who are seriously considering containers in production, and any particular experiences that you might have?
If there are any larger customers that are running containers in production, not that I know of today. What? Well, yes, Google is, but they're not a customer of ours. But yes, so Google on a large. Yes, so Docker, well, not Docker environments, container environments. So Google has been doing containers forever, for much longer than Docker existed. And basically what Google has been doing in, I don't know, last 5, 6, 7, 8, 10 years maybe, they don't really tell you how long. That is all coming together in a project called Kubernetes, which is on GitHub. And basically, Google is making all of that technology that they've been using forevermore available in the Kubernetes project. Kubernetes is really fast moving. It helps you to deploy clusters of containers. And actually Google Compute Engine, what happens there is that every workload runs in a container. So when you run a virtual machine in Google Compute Engine, it actually runs inside of a container, okay? So everything in Google runs in containers. And I would say Google is the largest shop that uses containers. Other than that, I don't really know of anybody that is running containers in a production environment like that, or even similar to that. Especially not stuff that's exposed to the outside world. So the question is if there are experiences with other servers other than web servers. Currently, the focus, I think, is mostly on web applications, and the trend with Docker is really to go into the microservices operation, which basically means a service that does a very, very small set of, that provides a very, very small set of functionality, and that can be fully automated, so that you can really get to the point where you can very quickly restart your container. Okay, so in the case of the security update, you could go in, okay, say I have 100 containers that run the same microservice, and each container is fully automated. So if it gets started, then it automatically connects to the database backend or whatever it does, right? And all of that is fully automated. So that's the general idea. So that when I do run zipper up commit shut down, restart, I can do that in sequence on I can say, okay, I'm going to do 50 at once, and then the other 50 carry the load while these come back up, and then I do the next 50, right? So that's the general idea, but all of that has not really been tried out. As I said, there are currently, to the best of my knowledge, no best practices for any of this that people can just, where there are recipes that people can just follow. Other questions? Andrew? Yeah, so the question is about managing the containers. While currently, management from containers exists on at least 2 levels, right? The container itself as it is running, and there's also an issue with terminology, right? Because when we talk about a container, it can be either the image, which rests on your disk file, or it can be the running container. And in the common language that containers are talked about, there's not really a differentiation between the container that sits on your disk and does nothing and the container that is actually running, right? We talk about virtualization, we talk about images and instances, and then well, the instance is the running thing and the image is the thing on disk. But in the container world, we always talk about container, and it is not really certain if the thing is running or just resting on disk. And so as far as management is concerned, to come back to your question, it is, well, okay, so when you talk about container management, are you talking about the running container, meaning the stuff that's actually inside, or are you talking about the container that happens to be resting on disk that you can start at any time, okay? So if I look at what's running inside, theoretically, you can use the current management tools, okay? So for example, I could hook a running container into SUSE Manager if I wanted to, right? That is certainly possible. And then I can push my updates out, okay? And as long as the updates that I'm pushing out don't require the service that's inside to restart, I'm okay. But if I require that to restart, then again, it goes back to the earlier discussion, then I have to do a commit and then the restart of the container, or the update is really useless, right? And so then for the next layer, for the outside layer of saying, well, the container file or the image that rests on your disk, we saw earlier well, I don't know if everybody, but earlier, Joseph presented a new module in YAST that presents container information in YAST, right? And so there is work going on in that direction. And YAST will at least show you the containers that you have on your system. But currently we have nothing that would say, okay, this container X is related to Docker file X, and Docker file X contains this and maps this back to the repositories where the stuff that you built the container from comes from, right? So that connection is currently missing, and eventually that will have to be closed to make that manageable. And as far as the build environment is concerned, so the Docker build environment, which is the Docker files, those you can just manage through Git, for example, or some other source control file mechanism. Well, so the question is about SSH keys and certificates. And, oh yeah, I'm over time. Okay, sorry. So that's the last question. Sorry. So basically, you can just map those into your container as a volume. And you can just point them to your file system on the container host. And then when you restart it, it just gets remapped, and then the stuff is there. So there's not really a lot of effort to handle that. So, and with that, I'm out of time, so I can't take any more questions. Thanks for your attention.